Good morning. I am Mrs. Saksari Jovita, Assistant Professor, KCS Kasinagar College of Arts and Science. In this video, we are going to discuss about Q data structure. And the topic which we are going to discuss is about Q, implementation of Q data structure, type of Q, basic operation, complexity analysis of Q operation, and some application of Q. Q. Q is an abstract data structure. Unlike stacks, a queue is open at both its ends. One end is always used to insert data and the other is used to remove data. Queue follows first in first out methodology. That is, the data item stored first will be accessed first. So as we understand that in queue we access both ends for different reasons. And also the first element is inserted from one end called the rear, and the removal of existing element takes place from the other end called as front. As in stack, a queue can also be implemented using array, linked list and stack. The easiest way of implementing a queue is by using an array. There are two variables, that is front and rear, that are implemented in the case of every queue. Front and rear variables point to the position from where deletion and insertion are performed in a queue. Initially, the value of the front and queue is -1, which represents an empty queue, and we can insert an element at rear point, and the rear point value will be incremented by 1, and we can delete an element from front point and the front value will be incremented by 1. But although the technique of creating a queue is easy, but there are some drawbacks using this array data structure. First one is, one of the most common problem which array implementation is the size of the array, which requires to be declared in advance, and the extension in the array size is time taking process and also impossible to perform at runtime. And the second reason is memory wastage. The space of the array which is used to store queue elements can never be reused to store the elements of that queue, because the elements can only be inserted at front end and the value of front might be so high, so that all the space before that can never be filled. So due to these reasons, array implementation is not efficient. Queue implementation using linked list. Due to the drawback, the array implementation cannot be used for long scale applications. One of the alternate of array implementation is linked list implementation of queue. In linked list queue, each node of the queue consists of two parts. One is data part, the another one is link part. Each element of the queue points to its immediate next element in the memory. In linked queue, there are two pointers maintained in memory, that is front pointer and the rear pointer. The front pointer contains the address of the first element and the rear point contains the address of the last element in the queue, and insertion and deletion performed at rear and front respectively. If the insertion happened, then the rear point will be incremented, and if the deletion happened, and the front position will be incremented. Types of queue. Queue data structure has some of following types: simple queue, circular queue, priority queue, and double-ended queue. As is clear from the name itself, simple queue let us perform the operation simply. That is, the insertion and deletions are performed likewise. Insertion occurs at the rear of the queue and deletions are performed at the front of the queue list. All the nodes are connected to each other in a sequential manner. The pointer of the first node points to the value and the second node points to its value, and so on. The next is the circular queue. Unlike the simple queues, in a circular queue, each node is connected to the next node in sequence, but the last node also connected to the first node. Hence, the last node and the first node also gets connected to making a circular link over. Next is priority queue. The priority queue makes data retrieval possible only through a predefined priority number assigned to the data item. Insertion in priority queue is performed in the order of arrival of the nodes, and the deletion, the node having the least priority will be the first to be removed from the priority queue. The last is double-ended queue or DQ. The double-ended queue allows the insertion and deletion operation from both ends of the queue. That is, we can insert an element at rear point and also we can perform deletion at rear point. In front point, we can delete an element and also we can insert an element in DQ. Here are some basic operations we can perform on queue. First one is enqueue. Enqueue means inserting an element, that is adding an element into the queue. The second one is dequeue. Dequeue means deleting an element, that is removing an element from the queue. And the peek operation gets the element at the front of the queue without removing it. Is full. Check if the queue is full or not. Is empty. It is to check if the queue is empty or not. The first operation is enqueue. In enqueue operation, the algorithms which we are going to perform in 4 steps. First one shows rear. If my rear point is greater than or equal to size minus 1, then write queue is overflow. For example, I am having a queue with 4 element space, and here I am having 1, 2, 3 and 4. So here my queue is full and the first position is noted as front point and the last one will be the rear point. If, as per my condition, if the rear is greater than or equal to size minus 1, that is my size is 4 minus 1, which is 3. So the value of that queue will index value of that queue will start from 0, 1, 2, 3. So the size of my rear point is greater than or equal to size minus 1. So it satisfies this condition. So I can write the queue is overflow, that is no place to insert a new element in my queue. So that I am writing like this. If not, if there is a space in my queue, then what I want to do is I want to increment the rear point as usual. So if there is, if I am having the queue with some extra space, I am having 1 here and 2 here and 3 and 3 here and one more space is empty. This is my rear point and this is my front position. So here the rear is not greater than or equal to my size minus 1. So I can insert an element. Here I am getting the element which I want to insert, that it be 4, and then I want to move the rear point to r plus 1, that my rear is moving to the 4th position, and here I can insert the element 4. Okay, if it may be a first element, then my front minus 1 will become front is equal to 0. So by using the fourth step, we can achieve the insertion of the element q in insertion of the element in q, that is NQ. DQ operation, that is removing an item from the queue. So for that, first I want to check whether the my queue is empty or not. Here I am having a queue with without any value, that is it is now empty. So I want to check if my front value f is equal to minus 1 means then my queue is empty, no element inside my queue. Okay, though, so that I can give a message my queue is underflow. If it is not empty, I am having some elements inside my queue, then I want to return the first element, because as per the queue concept, the first element would be deleted first. So here I am performing the deletion operation. So after that, here my f value will be 0 and here f is equal to 1. So after deleting this, my front position will be moved to the f is equal to f plus 1. That means here the second position, into the second position. And again, if I want to delete that element, I can perform only at the front. So I can delete the element 2, and again my front position will move to the third position. Now my front will be the 3. I am just incrementing the front position when I am deleting the element from the queue. Okay. This is the step we can use to dequeue the element from the queue. Complexity analysis of queue operations. Just like stack, in case of queue, we know exactly on which position new element will be added and from where an element will be removed. Hence, both these operations require a single step. So, the complexity of NQ operation is big O of 1, as well as DQ operation is also big O of n. To find the size of the element, size of the Q is also big O of 1. Next, some of the application of queue. Queue, as the name suggests, is used whenever we need to manage any group of objects in an order, in which the first one coming in also gets out first, while the others wait for their turn, like in the following scenario. Serving request on a single shared resource like a printer, CPU touch scheduling, etc., or using the queue format only. And also in real life scenario, call center phone call systems uses queues to hold people calling them in an order until a service person is free. Handling of interrupts in real-time systems. The interrupts are handled in the same order as they arise, that is first come, first served. And these are all some application of queue. Thank you.